Hello guys and gals, my name is Dr. Pettis at Dr. P Learning. At this channel, I teach project-based and hands-on CTE and STEM content. We focus on engineering-based projects, CAD, and 3D printing. If that is of interest to you, you're at the right place. Please like and subscribe to the channel so you can be notified when a new lesson is published. Okay, so let's get into today's lesson. In this video lesson, you will learn how to use a new sensor called the ultrasonic sensor to detect an object and light an LED when it senses something within a given distance. Components that are used in this are obviously our Arduino, our breadboard, our ultrasonic sensor. I have a couple of what we call jumpers here, these pin jumpers. We have our wires. Okay, I have a black, a white, a green, an orange, and a red, a 220 ohm resistor, and an LED. Okay, so what is the HCSR04? That's a good question. The HCSR04, or the ultrasonic sensor, is a sensor that sends a signal out, waiting for that signal to be returned. It sends an ultrasonic sound. Ultra refers to above, and then sonic refers to the sound waves. So the sensor is sending out a sound that is above the capability or your ability to hear something. Okay? So bats. Bats use sonar. Submarines use sonar as well. Ultrasounds. You ever had a baby picture? Those use ultrasound. So that's, again, these are a couple of ways that sound is sent above our ability to hear. So bat sends a signal out to look for food. The signal comes back, and the bat can determine if there's some food flying around in front of him or her or not. Okay. So what are we actually measuring? What is the bat measuring whenever he sends out his signal? Well, for starters, he is measuring distance between, measuring distance between himself and the other object. Also measuring size of the object. So he sends out a signal that's this wide, and then if only this much of the signal comes back, he knows that the object is small enough for him to eat. So I'm going to look a little bit at the ultrasonic sensor here. We're looking, here's where the signals are sent from the ultrasonic sensor. Okay. If we go from left to right here, these little pins, we see VCC, trig, echo, and ground, or G and D. So VCC refers to the power. So this sensor actually needs 5 volts to operate correctly. So we'll need to make sure that that's plugged into the 5 volt on your breadboard. On your Arduino or your Elegoo. We all know where pin 13 is, the famous pin 13. It's actually just on the opposite side. It should say 5V, the number 5 and the letter V on the opposite side. That's where the VCC will connect. The next pin is trigger. This is the output pin. This sends out a signal. And then the ground. G and D goes to ground. Okay, this is ground is this one here right by pin 13, if you remember. There's also a couple of grounds on the other side of the board as well. Okay. Now trigger echo, you notice I didn't say that there was a specific pin that they connect to. Well, that's where you're going to have to figure out where you would like to connect those pins to. And whenever I go over the code in just a few moments, I'll show you where I connected the pin, them, and then how to mark the code so that I know what each line of the code is doing. As I just mentioned, since this video was previously recorded, we have an update for you. All right, here it is. Trigger pin is at pin 10, echo at pin 9, and LED at 13. So we're going to go ahead and do that. We'll use green for our trigger. Okay, so our trigger is here. And the pin for that is pin 10. We're going to go put it right there in pin 10. That means that the echo is 9. I'm going to do the yellow, pin 9. All right. We've got our power. Let's see which side power is on. VCC is right here. And 5 volts is right there. Okay. And then, of course, our ground is on the other side. Okay. Plug into that ground right there. Okay. We've got our LED over here. Now, this says pin 13. So you can literally plug this into the board. Pin 13. If you want to run it to, say, pin 12 or somewhere else, you can put it on the board somewhere. But you will need to add a 220 ohm resistor to that. Actually, let's just use the ground from the ultrasonic sensor. As you can see here, I use the ground from the ultrasonic sensor for my LED, and I have my LED power in row, it looks like about 19 there. So we'll go ahead and plug the power from that into right there. Okay, all right. So here is the code. We're going to set a distance threshold. So this will be in centimeters. This is 30 centimeters away. So you can change this really to whatever it is that you want. Now we're going to do our setup as to set up our trigger as an output, our echo as an input, and our LED as an output. We'll also set up our serial monitor. The good thing about the serial monitor is that you can see how far away, in the serial monitor, you can see how far away your hand is from the sensor because it will give you live readings in centimeters. Based on this code, if we put our hand 30.5 centimeters away, what should happen? If we move it closer to 7.5 centimeters away, what's going to happen based on this code? What do you think? You can put the answer in the comments below if you know. All right. Next slide. I'm going to move my picture up there. Okay, so we set the trigger pin to a low setting, so it's off. We'll do a quick delay, and then we'll turn it on, and then we'll turn it off. So we have the light off. We're going to turn it on real quick, and then we're going to turn it back off on the trigger, and then we're going to have the echo read how far away that the nearest object is. Okay, and we're going to be doing so we're going to output that distance to the serial monitor in centimeters, and then our loop is that if the distance is less than or equal to our target distance, remember that our target distance we set on the previous screen to 30, it will write that the LED pin will be in a high state. Otherwise, it will stay in that low state. And then we have that short delay at the very end for stability of the microcontroller. Okay, all right. So that's what we're going to do now. We'll go ahead and plug this in. I am going to turn this. So see my hand comes into the picture. As soon as it does, see that the light does turn on. And that's when the magic happens, right? You put everything together, your blood, sweat, and tears. Okay, maybe that was a little dramatic. But your hard work, nonetheless, and your project worked exactly the way that you want it to. Now again, the distance that you're going to set here really is going to depend on your application. I want to thank you for visiting Dr. P Learning. Please remember to like and subscribe to the channel. We will see you on the next lesson.